In this video we are looking at center of mass of a two particle system. In the previous video we had seen center of mass of a two particle system having same masses, but in this case we're going to look at two particles having different masses. Let us say this is particle 1 and this is particle 2, and let us say their masses are different. Let us say m1 is 8 kilogram and let us say m2 is 2 kilogram. Right? And let us say where the center of mass of this two particle system will be. From intuition we can see that it will be somewhere closer to the particle with the larger mass, so it will be somewhere over here. Let us see that. Let's how this center of mass can be found out. So we will follow the same method that we have done in the previous video, but there will be some small changes here and there. Let us look at particle 1. So particle 1, x1 is equal to 1 and y1 is equal to 2. As you can see over here, x1 is 1 and y1 is 2, and the mass is 8 kilogram. And particle 2, x2 is 3 and y2 is 4 and mass is 2 kilogram. Right? So this is the details about the two particles. Right? Once again, let me repeat that we've shown them joined by a thin rod of negligible mass. Actually this rod is not there, but just to help us understand that this is a two particle system and these two particles are not isolated, we've shown a thin rod of negligible mass over here. Okay, let's proceed. So I want to find out the center of mass. So XCM, the formula that we used in the previous video was x1 plus x2 upon 2. But in this case, the masses are different, so I will have to introduce masses into the formula. And it turns out the formula for XCM will now become m1 x1 plus m2 x2 upon m1 plus m2. And this is understandable because the center of mass, the location of the center of mass has got a relationship with how is the mass distributed. So therefore in the formula for XCM, m masses are introduced. And if you kind of take the two masses equal, let us say the two masses are equal, then this will be m, this will be m, and here you will have 2m. So m will get cancelled and we'll go back to this formula which we had used for this two particle system having same masses. So this is now the equation for XCM, and let us put values over here. So I'll get 8 into 1 plus 2 into 3 upon 8 plus 2, and this will give me 14 by 10, which is equal to 1.4 centimeter, and 1.4 centimeter will be somewhere over here, okay. Similarly, let us find out YCM. YCM will be m1 y1 plus m2 y2 upon m1 plus m2, and that will be equal to 8 into 2 plus 2 into 4 upon 8 plus 2, and that will come out to be 2.4 centimeter. 2.4 centimeter, and 2.4 centimeter will be somewhere over here, right, nearly a little below the midpoint. So if I project this over here and if I project this over here, this is the location of the center of mass. So this becomes the center of mass, and you can very clearly see that the center of mass has shifted towards the larger mass. This is 8 kilogram, this is 2 kilogram, center of mass is near 8 kilogram. And the other thing that we have to keep in mind is that bigger the difference, that is, if this mass would be very large and this mass would be very small, the center of mass would go closer and closer to the larger mass. So this is how we find out the center of mass of a two particle system having different masses. Okay, if we look at it from a vector point of view, we can also find out a formula for finding out the center of mass. Let us say this is the position vector. This is the position vector for the first particle, and this is the position vector for the second particle. So this is position vector for the second particle. So, and I'll call them R1 and R2, right? And similarly, this would be the position vector for this would be position vector RC, right? Position vector of the center of mass, right? And this is the position vector of center of mass, and it turns out that the formula for RCM, therefore, right, will be very, very similar to what we have done, what we have used over here. It will be equal to m1 r1 plus m2 r2 upon m1 plus m2. So this is the method for finding out the center of mass with the help of position vectors. So if I know the position vector of particle 1 and I know the position vector of particle 2, then I can multiply with their masses and can find out the location for the position vector of RCM. Okay. This has kind of covered the center of mass of two particle system with different masses. In the next video, we will be looking at this particular equation more closely and try to find out how it is connected to forces acting on the two particles. Thank you.